There have been some stellar comments from our star contributors. But before we look at some of them, Randy Yates sent a link to a Barry Setterfield video which is very relevant to the last episode. I was introduced to his work in 1985 or 6. An Australian gave me a recording of one of his lectures on evolution and the timescale. I was so impressed, I contacted him and discussed his work. He sent me slides for that lecture. I'd done studies in evolution and in geology and in astronomy, and his lectures cast doubt on everything I'd learned about all of them. I was so interested in finding out whether what he was saying was true that I spent many weeks in several university libraries. I found that papers in the journals described observations which fitted well with biblical creation, but those observations were shoehorned into secular, materialistic hypotheses. I produced lectures of my own based on these studies. I soon found myself being invited to share those lectures all over South Africa. I owe a huge debt of gratitude to Barry Setterfield. But getting back to the link Randy sent, it's very relevant to the things we've been looking at in the last 2 episodes. You can find it at the link above.
The 0-point energy basically is electromagnetic energy which fills the vacuum. It's intrinsic to the whole fabric of space. It's intrinsic. It goes through everything in the universe, goes through you and me and so on.
Well, why is it called the 0-point energy?
Let me put it this way, Chuck. If you take a perfectly sealable flask and pump out all solids, liquids and gases out of it, you would think you had a vacuum, a good vacuum. That was the definition of a vacuum back in the 17th century.
Okay.
Okay. It was then discovered in the 20th century that that vacuum contains an incredible amount of energy. It's called the 0-point energy because it's there at absolute zero of temperature.
Okay.
Okay. And what it is, it's actually electromagnetic waves of all wavelengths that are appearing there. And these wavelengths are distributed in an unusual fashion. There are very, very few long wavelengths, but the shorter the wavelength is, the more there are of them.
That would be, yeah, okay.
Okay. And so it means that at the atomic level, the 0-point energy is a seething mass of electromagnetic radiation and electromagnetic waves. And so it actually has a huge effect on atoms, but it has very little effect on larger scale objects.
I run into physicists who tend to either dismiss or sideline or marginalize. They treat it as just some kind of academic idea rather than an actuality.
We met exactly this problem in episode 79, and we had some notable input from some of our sterling commentators. There's a very good reason why secular materialist physicists don't want to consider 0-point energy to be a reality. They hate the implication that the 0-point energy is nothing other than the ether which they had abandoned in order to dismiss the evidence that the Earth was stationary at the centre of the universe.
The 0-point energy was discovered as a result of an anomaly which science had come up against in the late 1800s, early 1900s. Theory and data were not agreeing as far as radiation curves were concerned. They'd tried all sorts of ways to overcome this problem, and every method of overcoming the problem had failed. In 1901, Max Planck, overcame the problem in a very unusual way. He inserted another term in the equations, h, which became known as Planck's constant, later on. And by inserting h, this term, into the equations, he was able to overcome the difficulty. Now, this was a pure mathematical device. It was mathematics for the sake of mathematics, and it worked, and as a consequence it was accepted. But this puzzled Planck because he was a practical man and he realised that there had to be some physical reason behind this constant in there. And then after 10 years of working on this, he came to the conclusion that, okay, we can rewrite our paper. And he wrote what is called his second paper in 1911. It was published, in which there was a good physical reason for the Planck's constant to be there. It was a measure of the strength of the zero-point energy. And the zero-point energy was filling the whole vacuum. This concept was worked on by Einstein, Stern, Nernst and others, and was proven to exist in the early 1920s.
We see here a point I've made in many previous episodes. Physicists willfully abandoned common sense and replaced it with mathematics. I'm sure there are those who remember Brett's take on this, the attitude taken by the consensus in physics. We mere mortals don't have enough intellect to understand the ways that quantum physics has shown reality to be. Common sense is utterly inadequate for the job. It's only mathematics which can solve the problem. When Planck realised that his ad hoc, purely mathematical H had a real meaning, physicists had gone so far into the purely mathematical recipe of quantum electrodynamics, practically all of them didn't want to know.
You see, in the 1920s, in the mid-1920s, 4 major papers were published on the basis of Planck's first mathematical exploration. Mathematics for the sake of mathematics. There was no physical reason. These papers had no physical reason for what was happening, but they used Planck's constant as a pure mathematical device to explain things and to explore possibilities. And this exploration led to what is now known as quantum electrodynamics, or QED physics. And
that's the general understanding even to this day then?
That's the general understanding even to this day, and it's based on Planck's first paper, not his second one.
See, I leaned on that for a lot of our materials.
Yes.
But you're telling me that there's another point of view under the covers emerging here.
Yes, indeed. In fact, up until 1925, when these 4 papers were published, there was a whole discussion going on about the zero-point energy and its effects on physics and so on, and its effects on atoms. And it does affect atoms because the zero-point energy has a large number of waves of all wavelengths, but the smaller the wavelengths, the more there are of them, so that by the time you get down to atomic size, you have a seething sea of activity of these zero-point waves. Anyway, what happened was that quantum physics developed using Planck's first paper, and in the development of this, all you had was a theoretical idea, a virtual idea for the zero-point energy. It wasn't a real construct, it was only a virtual construct, and this led to infinities and zeros in your equations. By the time 1962 came around, quantum physics had very, very well developed. But Louis de Broglie, who had published one of those 4 papers back in the 1920s, he had second thoughts about things. He looked back at what had happened. He said, I think physics has missed a key point here.
It takes a lot of guts for a guy to shift gears like that, isn't it?
It does. I must hand him full credit on this. And as a consequence of his exploration, Louis de Broglie said, okay, we should be looking at a real zero-point energy and classical physics in order to explain quantum phenomena. And this suggestion was taken up by a number of folk, and papers were published shortly after that. In fact, there are a number of papers paralleling the 4 papers which were published in the 1920s, which set quantum electrodynamics on its path. And these papers published in the 1960s to 1980s and later, these established stochastic electrodynamics, SED physics, as a result. And the word stochastic means random. and you'll get coming at this from the random waves of the 0-point energy. They're coming in all directions simultaneously and in random. And what is happening is that an electron or any subatomic particle is being battered by these random waves of the ZPE. And as a consequence of this random battering, the particle is moving around, it's jittering around like this, so you have uncertainty in its position and in its momentum and in its orbit, because an electron, for example, is being hit something like 10 to the 20th times per second by these battering waves of the ZPE, and in one orbit around the nucleus, an electron will be battered 18,700 times just in one transit of its orbit.
So this is really what lies behind what we call the Heisenberg uncertainty principle, isn't it?
There's a physical reason behind it.
So many people take that and misapply it, but that's neither here nor there. The point is that's the dynamic
Yes.
that leads to the physical implication.
Yes.
And so now, what is there are a number of aspects to QED that lead you to some very bizarre, not counterintuitive kind of conclusions. Are these modified by the SED?
Okay, well, for a start, you have the randomness of position. The random battering gives you uncertainty in the position and the momentum of your subatomic particles. And there is a physical reason behind everything which happens in your quantum world. And this physical reason is, in fact, the 0-point energy. And as you have a look at, there are whole papers have been published about this, and it would take a long time to go and explain them all. But the point is that there is now we have a physical reason behind it, instead of just a theoretical concept.
Okay. Does the SED impact our concepts of locality and non-locality?
Yes, it does. The idea that we have here in SED physics is that you have a real particle. It is in a real position, but you have a real 0-point energy which is changing its location, and as a consequence of this, you can account for a whole host of physical phenomena.
I guess one of the questions I'm asking, what's the status of SED in physics today? Is it starting to get traction? Is it starting to get, because I would gather this is the kind of discussion that's relatively rare. I don't, people just have embraced the QED. As you pick up journals and Scientific American, whatever, they deal in those terms. Is the SED starting to get, broader traction in
Yes.
the professional movement?
In fact, it is answering a whole host of questions that we've had that have never been satisfactorily answered before. SED physics, in fact, even though it's still a minority position, it is gaining increasing attention. And what you must realise, Chuck, is of course that QED physics had a 60 or 70 year head start on us.
Sure.
And so this QED has developed far more fully than SED physics has, but SED physics is overhauling things fairly fast in terms of explanations for phenomena.
We may be witnessing then some overturning or some major changes coming along in outlook, aren't we?
I see some major changes in outlook because what we have in quantum physics is a strange behaviour, a strange inherent property of matter, whereas in SED physics it says no, matter is being perfectly normal, it's just being battered by these impacting waves of the ZPE. So you can account for the de Broglie waves of electrons, for example. You can account for a whole host of phenomena here, just using SED physics rather than QED physics.
So although you may hear very little about stochastic electrodynamics, and continue to hear a very great deal about quantum electrodynamics, SED is making progress in explaining more and more of the incomprehensibility of QED. And just one more point about this video, Setterfield interacts with another thing we looked at in the last episode.
When the heavens were stretched as a result of the Big Bang, if you like, or As it says in the scripture, God created the heavens and stretched them out. We're told this 12 times in the Bible. Okay, so you have this stretching of the heavens. When you stretch the fabric of space, you're putting energy into the fabric of space. And this energy goes in as potential energy and then eventually changes to become the kinetic energy of the ZPE, of the zero-point energy. And this process takes a little time. It doesn't happen instantaneously. You know, when you have a kid on a swing, for example, you lift the swing way back, goes to a high point. That's all. The energy is all potential. You let the swing go, it moves down, and then at the bottom of its swing, it's moving at its maximum speed. It doesn't happen instantaneously. It takes time.
And getting back to the comments, there have been some very helpful contributions towards the origin of the George Wald quote, which we looked at in episodes 107 and 109. Marie sent a copy of the Congressional Record for November 30th, 1979. Thanks, Marie. I really appreciate your input. There was a debate in Congress about the teaching of evolution in American schools. The quote we are looking for is there, in part. There are only two possibilities. Either life arose by spontaneous generation, or it arose by supernatural creation. There is no third position. Wald is being quoted as a top authority. The source cited is Theories of the Origin of Life, which you may remember I had concluded to be the most likely source. But there's a point to note. The ellipses point to phrases missed out between the parts of the quote we are looking for. Having been alerted to this, I found that many instances of this quote include ellipses. Another of our heroes from the comments, More We Can Think, sent me a copy of Wald's paper from that book. It contains the propositions in the Congressional Record, as well as comments on Pasteur having proved the impossibility of spontaneous generation, comments about believing the impossible anyway because the alternative is anti-scientific, but it does not contain the latter part of the quote. That final part of the quote sometimes occurs by itself. More We Can Think also sent me a copy of Search for Certainty, where that famous quote is given exactly as I gave it. It also occurs in a discussion in Access Research, and in many other places too. But I failed to find the whole of that quote, as usually presented, in any credible source. Brett sent me the article from Scientific American of September 1958, which had also been put forward as a likely source. It's less convincing than the article from August 1954, which we looked at in detail in episode 109. It also contains parts of that quote, and similar ideas to the other parts too, but not the actual quote. Thanks, Brett. Your help has been much appreciated. It's obvious that all the points in that quote were frequently made by Wald. So that quote does not misrepresent his stated beliefs. But if he did put all those ideas together in one unit, it seems more likely to have been in a speech than in an article. I won't use that quote again as it stands. If I want to make the point again, I'll make my own extract from the August 1954 article. I'd like to thank 7EBR for raising this question. It led me to look at quite a bit of Wald's work, which I'd forgotten about. For example, his contribution to the mathematical challenges to the neo-Darwinian interpretation of evolution. While his paper on vicarious selection had always seemed to me to have little to do with the theme of the conference, it did, at least, give a mortal blow to Dawkins's selfish gene. It concluded that bacteria in the oceans had to consider the needs of fish more important than their own. But of course, he could no more consider that a serious problem for evolution than his many demonstrations of its impossibility from a chemistry perspective. But getting back to our star contributors, the recent comments have been rather special. Our favourite contributor, Brett, has not only debated in threads with me, but also with Jungle Jargon, Glynis, Tyconian, Earl, Alan, Seanite, Warren, Scott, S. Abhishek, Spotter, Mendon Kakareya, and Hubert. Thanks a stack, Brett. You keep us all on our toes and provide some very interesting ideas for consideration. I want to look at some of Brett's contributions next time. But one thing's clear to me about the comments on the recent episodes. Astronomers make confident claims based on reasoning about things we can only wonder at. They see light in their telescopes, which they interpret in terms of theories which they've accepted for so long that it never occurs to them that they could be wrong. Is it wise for us to follow their example? Hath not God made foolish the wisdom of this world? If any of you lack wisdom, let him ask God, that giveth to all men liberally, and upbraideth not, and it shall be given him. Thank you for joining me for this episode. If you enjoyed it, please like, subscribe, and press the bell so that you'll be notified as I release new movies. If you'd like to support this project, you're welcome to do so through Patreon. Find a link on my channel banner and in the description below.